April 13, 2029. The date humanity will remember as the day Earth came face to face with chaos. An asteroid the size of the Empire State Building, 370 meters wide, 20 million tons of rock, will skim past our planet at 30 times the speed of sound. Its name is Apophis, after the Egyptian god of destruction. And it's very real. This will be the closest flyby of an asteroid this large in recorded history. Just 31,600 kilometers, inside the orbit of our communication satellites. We are FACTSTORM, and our mission is to deliver the hard data behind the events that shape our universe. Subscribe now and activate the bell so you never miss a verified report. 2 billion people will be able to see Apophis with the naked eye. No telescope, no science fiction. Just the raw reality of a near miss. Scientists at NASA call it a cosmic stress test, a moment the entire world will watch, measure, and never forget. Imagine looking up at the night sky and seeing a moving point of light, knowing that under slightly different math, it could have been our extinction. Back in June 2004, Apophis was first spotted by astronomers at Kitt Peak in Arizona. At first, it looked like a routine discovery. But when orbital data came in, the world changed overnight. The numbers gave a 2.7% chance of impact with Earth in 2029. It was classified as a level 4 on the Torino impact scale, the highest ever recorded. If that impact had happened, the burst of energy released would equal 1 gigaton of TNT, more than 20 times the largest nuclear explosion in history. Cities would vanish. The blast wave would devastate everything for hundreds of miles. It wouldn't end humanity, but it would scar civilization forever. It's a terrifying scenario. In 2021, new data confirmed we are safe, but the initial realization of this threat was a wake-up call for our entire species. If you believe planetary defense is one of the most critical missions of our time, support the channel with a like and share this vital information. Over the next decade, radar stations at Arecibo and Goldstone scanned Apophis relentlessly. New trajectory models refined its orbit until, in 2021, NASA officially cleared it of all impact risk for at least the next 100 years. But that didn't end the story, it made it even more fascinating. Because when this asteroid flies by Earth in 2029, it won't just come close. It will be changed. Forever. As it passes through the gravitational field of our planet, it will experience tidal forces powerful enough to distort its shape. Cracks may open. Regolith, the loose dust and rock on its surface, could slide downhill, exposing untouched material. The asteroid could even begin to spin faster, its rotation warped by Earth's pull. A world-sized hand twisting a mountain of stone. The encounter will also change its orbit. Apophis, currently an Atom-class asteroid, will transition into an Apollo orbit, meaning it will shift from orbiting mostly inside Earth's path, to mostly outside it. Our planet's gravitational tug will literally rewrite its place in the solar system. NASA and ESA aren't leaving this to chance. They've mobilized an entire planetary observation network. Telescopes on every continent, from Hawaii to South Africa, will capture the flyby. Goldstone's radar will image the asteroid down to 1.8 meters per pixel. Even private companies are preparing satellite camera arrays to measure gravitational deflection in real time. But the stars of this story are two missions, OSIRIS-APEX and RAMSES. OSIRIS-APEX is NASA's deep space operator, the same craft that brought samples from asteroid Bennu back to Earth. After completing that mission, engineers reprogrammed it for one final job, to chase Apophis. It will arrive weeks after the flyby to orbit, observe, and even fire its engines near the surface to stir up dust. Its goal: learn how asteroids respond to gravitational stress. ESA's RAMSES mission will get there first. Launched in 2028, it will rendezvous with Apophis before the flyby. Equipped with 2 CubeSats, it will record close-range images, analyze magnetic fields, and measure the subtle twisting of the asteroid as Earth pulls on it. The combination of NASA and ESA data will create the most complete asteroid reconstruction in history. This isn't just about one rock. Apophis 2029 is a full-scale rehearsal for humanity's survival. It gives scientists the chance to validate the systems that could one day save us: better radar tracking, impact simulations, and deflection strategies. It's the next step after DART, the Double Asteroid Redirection Test of 2022, when NASA successfully changed an asteroid's path. The future of planetary defense depends on what we learn from Apophis. If Apophis were to hit the ocean, it could generate tsunamis over 10 stories high. If it struck land, the shockwave could wipe out a region the size of France. These are not guesses, they're hard calculations derived from kinetic models. The 2029 encounter gives scientists a giant data point to refine those models. Real observations. Real measurements. In real time. For the rest of us, it's a once-in-a-lifetime show. On April 13, 2029, a Friday, people across Europe, Africa, and parts of Asia will lift their eyes and see something unbelievable. A pinpoint of light racing through the stars, brighter than most visible satellites, moving silently across the night sky. It will pass over at around 1845 UTC, glowing just enough to stir primal awe. Think about it, for billions of years, Earth has been hammered by asteroids we never saw coming. Apophis is the first truly large one we'll witness up close, before impact. When it's gone, it won't return for more than 7,500 years. But the question it leaves behind will echo for decades: what if next time, there's no miss? The 2029 encounter has already sparked global conversation about preparedness. For the first time, planetary defense feels tangible, not theory, not fear, but science. Apophis doesn't need to strike Earth to remind us what's at stake. It reminds us that our species exists by the grace of probability. So when that night in 2029 comes, don't just watch it on a screen. Step outside. Look up. That dot of light is a visitor from the dawn of the solar system. It's been traveling for billions of years for this encounter, a few minutes that will redefine our understanding of near-Earth space. And when it passes by safely, remember what it truly means. For once, chaos blinked first. We have missions to observe, and we have proven we can intercept. Which strategy do you believe is more critical for our long-term survival: early observation like OSIRIS, or active interception like DART? Let us know your defense plan in the comments below, and check the pinned comment to explore the FACTSTORM channel. Follow FACTSTORM.